All right, 8th graders, lesson 66, special right triangles. So, one, we're going to look at a triangle in a square, and the other we're going to look at a triangle in an equilateral triangle. So, if I divided that way, there, and I divided that in half that way, and this is the half that we'd be talking about over here, and we could color in this half over here. To write some facts on there, we could say this triangle in that corner you would have 90 degrees. This corner and this corner we'd have 45 and 45. 45. Here I'd have 90 again, but I wouldn't have 45 and 45 over here. Here I'd have a 60, and here I would have a 30 degree. So those are the types of triangles that we're going to talk about today. 45, 45, 90, and a 30, 60, 90. Example 1 asks us to draw the two special right triangles from the beginning of this lesson and indicate the measure of each interior angle. So again, we're drawing it as though it's half of this, and this would be 90, 45, 45. And this is half of a equilateral triangle. That would be 90 down there. The smaller one would be 30. The larger angle would be 60. So we call this a 45, 45, 90 triangle, and this one we call a 30, 60, 90 triangle. So we'll need to get used to hearing those names. Now we're going to talk about the lengths of the sides of those two types of triangles. So again, we have 90 degrees there. This would be 45, 45. This is 60, and this is 30. The length of this side, we say, is 1. We're going to call the length of this one 1, which means the length of this side will also be 1. So if each of those is 1, using the Pythagorean theorem, 1 squared plus 1 squared equals the square root of those two together, which will be 2. 1 squared plus 1 squared is 1 plus 1. So this side will be the square root of 2. So in a 45, 45, 90 triangle, we can say that the sides, these two will match, and this will be the square root of the square of each of those. So the hypotenuse here, the long side, is the square root of 2. Over in the other triangle, we're going to assign a 1 again, even though they don't match, they're not similar, but we're going to assign a 1 to that side. In a 30, 60, 90 triangle, if you remember, this side also would be a 1, so the length of those two together would equal 2. Keep us from confusing that, I'm going to erase this over here. But if you remember that, this would be 1, and this is half of the length of the side, so 1 plus 1 would be 2. And the height here, where we split it down the middle, that's going to be a little bit different. Again, you have 1 squared plus 2. Because, sorry. We're going to just put a line through here, so I got you a little bit confused there, but 1 squared plus, we don't know that third side, equals 2 squared. So solving that, this would be 4 minus 1, so this side would be the square root of 3. So we can say the length of this side over here is the square root of 3. So in a 30, 60, 90 triangle, using those basic numbers, we can say this side is 1, this will be double that, 2, and this will be the square root of 3. Okay. All 45, 45, 90 triangles have that same ratio of, we say, 1 to 1 to the square root of 2. And all 30, 60, 90 triangles have a 1 to 2 to the square root of 3 sides. Noting too that the longest side is the 2. The square root of 3 is going to be 1 point something. Alright, let's go on to example 3. Here we have the shortest side of a 30, 60, 90 triangle is 5 inches. What are the lengths of the other sides? Well, we know that this is really half of the whole side, so we double it, and we know the side will be 10. Using those 2 bits of information, we can say 5 squared plus, and I'll just call it n for now, n equals 10 squared. That's going to be 25 plus n equals 100. 100 minus 25 is 75. And we find the square root of that 75. Now, there's also another way to do this, and that is, or to understand this, and that is that 5 is the shortest side, and we simply apply that scale factor of 5 to the 2 other sides. So, since this becomes a 10, we can do the same thing over here. We can say, if you remember, this is always 1, 2, and the square root of 3. So we're going to say that n equals 5 times the square root of 3. It'll be 5 times the square root of 3, since our scale factor is 5. So our answer for the 2 other sides would be these 2 numbers. The one side, the hypotenuse, the longest side would be 10, and the other side would be 5 times the square root of 3. Example 4. Here we have a traffic sign in the shape of an equilateral triangle that has sides 12 inches long. What is the area of the front of the sign? Now, area for a triangle equals base times height, and then you can either divide by 2 or multiply by a half. Doesn't matter. So using this, I need to find the height right here. Now, using the information that I just learned, this will be a 6. This will be 12. And we can say here that we've got a few other things in a 30 or 60 60 and or 30 60 90 triangle. We can use those same side ratios, and if we remember, the scale factor is 1, the square root of 3 to 2, so the scale factor here is 6. So I'm going to multiply 6 by this number. 6 times the square root of 3 is going to be the length of that side over here, of the height. So I'm going to put that into my formula over here. The base is going to be 6. That's right here, just as half the side. The height is going to be 6 times the square root of 3. So I should put that in parentheses. And I see I made a mistake here. Area should be actually the base. We're doing the whole triangle, not half of it. So it should be 12. 6 times the square root of 3, and then times 1/2. So 6 times 12, I can multiply that there. 6 times 12 will be 72, and half of that is 36. So the area will equal 36 times the square root of 3. And that's all the further I can go at this time. Add my label there. And that will be my answer. 36 times the square root of 3. Now, to estimate these measures, square root of 2 is approximately 1.41, and the square root of 3 is approximately 1.73. So we can use those here, and example 5 gives us an opportunity to estimate. Major League Baseball diamond, it's a square, 90 feet long on each side. If a base runner tries to steal second base, the catcher throws the ball from home plate out here to second base. How far does the catcher throw the ball? Well, if we divide this triangle in half, we have a 45, 45, 90. So this is 90, and this is 90. And so from here, if each of these are 90 feet long, this side over here will be 90 times, remember, the square root of 2. So the baseball player is throwing the ball 90 times the square root of 2. That's his distance. Now let's approximate that. We take in the square root of 2 is approximately 1.41, and we can multiply that by 90. 9 times 1 will be 9, 9 times 4, that'll be 36, 9 times 1 will be 9, 10, 11, 12, and there are 2 numbers after the decimal place. This is a 9, so I'm going to round that up, so I say approximately 127 feet is the distance that he would throw that. So again, we go back to this side right here. The length of it is 90. That's our scale factor times the square root of 2. That's it for today. A lot of new stuff, totally new concepts. You'll probably have to look back here. But the main thing to remember, show here, is that in our 30, 60, 90 triangle, this is 1 and 1 and the square root of 2, which is 1 times the square root of 2. So whatever number is the length of the side, we're just going to substitute that in the front of the square root of 2. In our 30, 60, 90 triangle, that was 1, that was 2, and we figured this is square root of 3. So because this is 1 times the square root of 3, whatever number you put down here, you will also put in front of the square root of 3 there. So how do we know what number to put in front of the square roots? We know what number based on whatever we put in this place down here or on one of the lengths of the sides in that type of triangle. So hopefully that is a good reminder. And if you have troubles with that, always ask and look back here at lesson 66.